Hi everyone, so C3R method this time. You don't know yet what the R method is, but the R method is when we can get trig stuff into the form of R cos x plus alpha or R sine x or theta plus alpha or minus alpha or something like that. That's what the R method looks like. In class we're going to investigate, well, what situations do we really need to use the R method, but this is a perfect situation for it to solve cos x plus sine x equals 1. It can be done without the R method. For example, you know through double angles that 2 cos squared x by 2 minus 1 plus 2 sine x by 2 cos x by 2 equals 1. So what I'm trying to do is use double angles to do this. But in this conversion, it's not obvious what to do because your minus 1 would cancel and make this 2 here. But then what, you divide everything by 2, you still can't take a factor either side. Oh, well, let's see. Divide by 2 either side, so cos squared x by 2 plus sine x by 2, cos x by 2 equals 1. And then, oh man, not much we can do here, is it? I can't move that over and then make it all equal to 0 and factorize. That's not going to work. Can't factorize the cos and the cos because I've still got a 1 on the other side. Really difficult. Maybe I should convert the cos. Sorry, maybe I should convert the cos x and the sine x a different way. So cos x is also 1 minus 2 sine squared x by 2 plus 2 sine x by 2 cos x by 2. That 1 cancels that 1, that's good. So I got minus 2 sine x by 2 squared plus 2 sine x by 2 cos x by 2 equals 0. So you could take out the factor of, divide everything by 2, that's gone. The sine x by 2, take out the factor of cos x by 2 minus the sine x by 2, and you have got it now, because now sine x by 2 equals 0, or cos x by 2 minus sine x by 2 equals 0, and therefore tan x by 2 equals 1, which you can solve by bringing that over and dividing everything by cos. But that was horrible, wasn't it? That was horrible. And if you don't know your double angle stuff that well, you're very unlikely to spot that, right? So this is where the R method comes in. And the R method will do, like this one can be done then using double angles, but it was hard. But there are some situations that you can't do it with. Now, what I'm getting at, let's change this to theta, is when things are in the form, so when trigs are in the form of this, a mixture of coses and sines, this is important. So when do you use the R method? When you got a mixture, so when you got a mixture of cos and sine, cos and sine, when you've got same angle, so here theta and theta, when you've got constants in front of sine or cos, sine and cos, so here A and B, and when whole thing equals a constant. If it didn't equal a constant, then you could do something else, which we'll talk about in class, which is much easier. So this does fulfill this criteria, because here A and B equal 1, and you do have a constant equal 1. Okay. Now, in order to solve this then, this problem cos x plus sine x equals 1, first off we're going to discover, well, how do we get to this R method thing in the first place? And we're going to do that by looking at the graphs of sine squared plus cos squared is 1 and using a similar logic after. So most people probably haven't seen the sine squared x, which looks like this one, and the cos squared x, which looks like this one, graph. Now what I can literally do is by eye C, we know that cos squared plus sine squared equals 1, and we can look at the graphs to tell us that. So y value 0, y value 1 added together is 1. Here, this is pi by 4. Now cos of pi by 4 is 1 over root 2, and sine of pi by 4 is 1 over root 2. So therefore square it, and add, that's a half plus a half, which equals 1. So this is 1. 0 plus 1, that's 1. 1, 1. So add the two graphs together and they always equal 1, which is what we wanted, right? I can now apply the same logic then to the question in hand, which was cos theta plus sine theta equals 1. But first, let's put in our sine x then, and let's put in our cos x. So here's sine x, and here's cos x. Let's do that again and add stuff together again. So this is like our pi by 4, isn't it? Here's our pi by 2. Here's our 3 pi by 4. Here x is about pi. And all the way up to 2 pi. So let's literally add the dots. So 0 plus 1, that's 1. Here we know cos of pi by 4 and sine of pi by 4 is 1 over root 2. Times that by 2, that's 1.4 something. Here, we got 0 plus 1, so there's 1. Here we got about 1 over root 2, subtract 1 over root 2, so that's 0. Here we got 0 minus 1, so that's minus 1. Here we got minus 1 over root 2 minus 1 over root 2, so that's minus 1.4 something. Keep going, 0 plus 1, 0 minus 1 is going to be minus 1. And we can keep going along. Now if I join my points together, like so, and then actually use autograph to see if I'm right. So I reckon if we add those two graphs together, we get my red graph. And huzzah! That purple graph is almost bang on, isn't it? Bang on what I had before. There we go, there's the purple graph. Now that purple graph represents sine x plus cos x. Surely we can see that this graph, though, looks a lot like cos, doesn't it? Or sine. Doesn't matter, because cos and sine are just a translation of each other anyway. They look like cos and sine, except they look a little bit different, don't they? They look a bit bigger. Cos and sine normally go between 1 and minus 1, but this is going to me about between 1.4 and minus 1.4. So the graph cos or sine has been stretched by 1.4, roughly. So I'm making a guess at the moment of what these things look like, and I'm just going to focus on this bit for now. Now also, cos starts from here. That's where its turning point is, isn't it? So it looks to me like it's been moved over. It's been translated. It's been translated to the right, which therefore means I'm going to have a minus in there, starting my x. It's been translated to the right by, I don't know. Let's say, I don't know how far across that is. To me that looks about 0.7. So that's my guess of what this thing is roughly the same as. But I can't just use guesses and graphs and stuff. This is maths. We have to be precise. And that's where the R method comes in. And let's see whether I'm being precise or not. So I'm saying that this thing, notice that the R method I told you at the start was R cos x plus alpha. So I reckon that R is 1.4 and I reckon alpha is 0.7. But let's check that out. So R cos x plus alpha, let's start from that first. If through the addition formula, we know that that's R cos x cos alpha minus R sine x sine alpha. But here's a plus, not a minus. And also, I told you that we reckon we translated it to the right. So And actually, your addition formula has to match the situation in hand. So if there's a minus there for cos, we know there's a plus there. That's good. I'll rub this out. And we're also saying that this R method is the same as our cos x plus sin x. Don't care about the 1 at the moment, forget the 1. So if these two things are the same, I've got cos, and the coefficient next to cos is 1, isn't it? So therefore the number next to cos x here needs to be 1. So r cos alpha must be 1. Got the plus. Here we got a sine. The coefficient of sine over here must be 1, and the coefficient of sine x here must be 1. So r sine alpha equals 1. If I want to find out what r is then, because remember my objective is to find out what r and alpha is, I could use quite quickly some common rules, or the common formula identity, cos squared plus sine squared is 1, because this thing squared is r squared cos squared alpha, isn't it? Plus this thing squared, r squared sine squared alpha, must equal this thing squared plus this thing squared. So I'm saying r squared, if I take a factor out here and here, cos squared alpha plus sine squared alpha is 1 squared plus 1 squared is 2. We know that in every situation, cos squared plus sine squared is 1. So I'm left with r squared equals 2, so r equals root 2. Not plus or minus, because we're talking about a scale factor stretched. So r is root 2. And what is root 2? Well, root 2 is 1.4142. And I reckoned it was from, I guess, 1.4, didn't I? So we're nearly bang on for r. Nearly bang on, so I'm happy with my guess. Fantastic. Now we need to find alpha. Well, to find alpha, r sine alpha over r cos alpha, we could just divide them. It's the same as 1 over 1. The r's cancel, sine over cos is tan, alpha is 1, so therefore alpha is tan to the minus 1 of 1, which is pi by 4. And pi by 4, in my calculator, says is 0.785. I guessed that it was 0.7. So yeah, I'm pretty close. I'm happy with that. That's fantastic. So that's a double smiley face. So there we go. We've got alpha. So what I'm saying is that this thing here, which was really difficult to solve, is now very easy to solve, because we know it's the same as root 2 cos x minus pi by 4 is 1. And now we can solve this. So to solve, cos x minus pi by 4 is 1 over root 2. Cos to the minus 1 of that is pi by 4, right? We also have minus pi by 4 because it's cos. Remember to check your domain. So x minus pi by 4 between 3 pi by 4 and minus 5 pi by 4. That's sorted. So therefore our solutions must be pi by 4 and minus pi by 4, and that's it, because if we add 2 pi to either of these, or minus 2 pi to either of these, they're not going to fit. So therefore x equals pi by 2, adding that over, and 0. And if we just check the graph, if I put in y equals 1, that blue line there, you can see, bang, that they do in fact cross at 0 and pi by 4. So I'm really happy with that. That's fantastic. Now, let's move on then to a formal example of where we can use this. So here's a formal example. Let's just make this a bit smaller. So 24. Okay. So let's consider this scenario. 3 sine 2x plus 2 cos 2x equals 1. We're in degrees this time, remember. Is this in R method form? Yes, because we need R cos theta, b sine alpha is a constant. We do have a mixture of cos and sines. We do have the same angle. We do have constants next to sine and cos, and it does equal a constant. Last time we had r cos. This time I'm going to put it in r sine, well, because the question tells me to, but it literally doesn't matter. But if the question says it's, then you've got to put it in that way. But it doesn't matter if I use sine or cos. They're a translation of each other. General rule of thumb, if they don't tell you in advance, just use the one that comes first. So if sine comes first, I'm going to use sine. So let's do that again. So solve. So r sine 2x plus alpha, start by what it wants you to start with. Expand it out as the addition formula. So we know that the addition formula for sine is r sine 2x cos alpha, plus in here, so plus in there, right? So plus r cos 2x sine alpha is the same as 3 sine 2x plus 2 cos 2x. I don't care at all about the 1 yet, because I'm just putting it in R method form. Sine 2x is the same, sine 2x is the same, so therefore the 3 must equal the coefficients of sine 2x, so r cos alpha is 3. Cos 2x, so therefore r sine alpha must equal 2. To find r, remember now we can just shortcut it, because you know that sine squared plus cos squared is 1. We can just shortcut it and say r would be this thing squared plus this thing squared, so 3 squared plus 2 squared equals root 13. There we go. Now we need to find alpha. And tan alpha, remember, sine over cos, equals 2 over 3. Normally you've got to give alpha to say 3 sig fig. So tan to the minus 1, 2 by 3, in degrees, is 33.69. Let's do it to 4 then, doesn't matter because it hasn't said. To 4 sig fig. There you go. Okay, so now it wants us to solve. Before we wouldn't be able to touch that, but now we absolutely can. So we get root 13 sine 2x plus our alpha equals 1. So quick solve. Well, that's not that quick, it's a bit nasty, but I can start off 1 over root 13. So we get 2x plus 33.69 equals sine to the minus 1, 1 over root 13. So that's 16.102 degrees. Because it's sine, 180 minus that, there's your next principal solution, 163.898. And also we'll fix our domain. This is just C2, isn't it? Our domain is here, so we'll just make that adjustment. So 2x plus 33.69 is now between 180 times 2 plus 33.69. I'm just doing this to help you if your C2 trig is rusty. So that's 9 here. And then we have our minus 180 times by 2 plus 33.69. And that's minus 326.31. So there you go. That's what we're working with. So now we can start adding 360 and subtracting it from these results. So in range, in domain. So answer, so 16.102 plus 360. That's not in range. Minus 360 from it. And you get minus 343, which again is not in our domain. That's too small. Let's try the 163.898 though. Minus the 360, and I get minus 196.102. And now we can actually finish this off. That's all the ones that are going to be in the domain. So 16.102 minus 33.69. all divided by 2 is minus 8.794. And 163.898 minus 33.69 divided by 2 is 65,104, and minus 196.102 minus 33.69 divided by 2 minus 114.896. There we go. There's all the answers, and you can check them by whacking them in your calculator. So normal C2 stuff applies. Let's move on to part 2 and 3 then. So just quickly clone that one, and we'll clear the ink. Okay, so part 2 says find the min-max of P of x equals this thing. So, completely new question, but using the same info that we just had here, we're just disregarding this 1. So P of x is 3 sine 2x plus 2 cos 2x. It's asking us to find the largest or smallest value of P. We know from our previous work that this is the same as root 13 sine 2x plus 33.69 degrees. Right? That's what this is. Yeah? So what's the smallest, so P of x min that this can be? 13, or root 13, doesn't change, does it? That's not going to change. It's a constant, whereas sine changes. Sine varies between 1 and minus 1, doesn't it? So times it by root 13, and this is going to vary between root 13 and minus root 13. So there we go. So what's the highest and lowest points? Well, you can see the highest point is r, root 13. So that's actually your maximum, whereas P of x, your minimum, equals minus root 13. That's the lowest point that it's going to go to, isn't it? So it's going to be r and minus r. That's done. Part 3, this time a bit harder. H of x equals 11 minus 3 over 4 plus 3 sine 2x plus 2 cos 2x. Looks horrible. It wants you to find the maximum value of h. Well, make it look like the R method form, because it will massively help you out. How would you approach that? You can't. So if you recognize that that bit is the R method form that you just worked out, now you can absolutely slam it, because like I said before, 11 doesn't change. That's not going to change. The 3 on top's not going to change. The 4 isn't going to change. This thing is the only thing that can change. So if we want the maximum value of h, we need the smallest, we need this fraction to be the smallest it can possibly be, don't we? Because it's 11 minus something. So what's the smallest that fraction can be? Well, it has to be when the denominator is the largest it can possibly be. And the largest it can possibly be is root 13, isn't it? So this is the maximum h can be, right? Make sure you understand that logic. And it also says find the maximum value of h, which you've done, and the smallest positive value that this occurs. This occurs when sine, we just agreed it. When the sine part equals 1, when the sine is at its maximum point, right? So now you're just literally finding the first positive x value where this is the case. So 2x plus 33.69 is sine to the minus 1 of 1, which is 90 degrees, and therefore x must equal the smallest value, 90 minus 33.69 divided by 2, 28.155. And the degree of accuracy, it will tell you what it wants it to be. Normally 1 dp or 3 sig figures, fine. And that's it. That's it for the R method. Lots more to practice in class.